I think it's a bit too loud.
I think I'm gonna see if I can bring this volume down here.
Now it's better.
Make anything softer?
Yes, works. Fixed.
Nice.
Yeah, it's on a delay of 30 seconds.
We should start here. Saying.
Okay, perfect. You can put it louder on the computer now.
So we can hear people.
Yeah,
That's good.
nice. Finally,
Okay.
we just need to remove us from the view.
Oh, it's fine. Us can stay. Let me just.
All right.
So we can hear people now. Yay! It works.
Nice.
Okay, now I need to send. Well, we should mute because they can hear everything we're talking about. Oh, wait, I'll mute the other source. Did you see? We're live. We can stream.
Right.
Yes, it took 2 laptops and plus an extra one, but we can stream. Yes.
Why the stream?
This will be live stream. I'm gonna send out. Yes. This one runs OBS.
Yeah.
And I'm connected to this one, so we can share the meetups and everything, so we can send the slide and everything.
Okay.
Yeah, you made it work?
Yes, I made it work, but now I need a power supply because the battery. I hope there is here.
Normally this thing.
Yeah, this one is a.
Yeah, I was trying to convince people to give us Linux here, but if we want to give us Linux, then we would have more people to say.
Can you plug this in? Thanks. We need this one. Without this one, it doesn't speak.
They said it's gonna be like 105 people.
Yeah, if we're lucky because of the trains. So there's
First,
also
we
that.
should send out a message to tell them that there's going to be a live stream, no?
Yes.
And also the security. Don't forget security.
Oh,
Security? Yeah, like we're checking in both downstairs and up here.
oh wait, let us mute because they can hear us.
It's okay. We're not.
I'll contact the whole group. Sounds nice, huh? The whole yeah, sure. Yeah, I'm okay with it. Wake some people up. I mean, we have some inactive members. Wait, members active within the last 12 months. Oh, that's a good point, yeah. And most important Slack. That's all. Hello, everyone. Have a live stream. Want someone join? On which YouTube is it? I created long time ago Amsterdam. What's the Wi-Fi password? Best from Amsterdam, all lower. Yeah, how we're gonna do it? Where do we? I'm guessing all the presentations on no, that's why I have 2 laptops. This is to make sure we can stream. For the presentation, you can actually so to make it simpler because there is a clicker and everything. It may be a good idea to do the presentation on yours. No, sure. Can we?
Send the link to my email, gustavo.famoso@messagebird.com. I'll share the presentation. Fine. Welcome.
was a roundabout way of speaking. So
I've seen worse, don't worry.
yes, but I will say sorry for any issues. This is our first live stream. Yeah.
Just let me know once.
Where should I send it, or can I Slack it to you or something?
I'm not sure if I'm in the Slack, but you can send this.
Right. Okay.
Yeah, but I'm not logged in.
Ah.
Just send me an email. Easier. Stop. Yeah, like that.
Oh.
At MessageBird.com.
Send live stream. Okay. So you can also send your slides. Okay. I can also send it to you.
Okay. Got yours?
Okay. I sent it to Slack also, sent out email, and
Do you want security about that screen?
no, it's normal. So far, every time that I can think of, every time we have to go.
Okay.
Wait, I'll send you.
Last question. What is the order?
Uh,
I think it's
here we go. So I'm gonna use yours to talk, and I'm gonna use this one to.
I'll let every station ready with full screen, so it's just one left.
Marcel didn't send me what he needs. He said,
Oh, do you mean Leandro? He
Oh,
actually sent me.
he sent you?
Yeah.
Yeah.
It's here. But I was thinking that maybe we should just present it here.
You know what I'll do?
Maybe we could just present it here, because it's
Okay.
easier.
Okay, deal. Or that also work? No, I sent it first, but why? So, yeah, those are obviously completely muted, so.
All right. Did you share this one with me? How much?
You're a football around?
No, I just opened for talk about
Ah, okay.
information.
Yeah,
So
okay.
usually.
Yeah. People start going, then you have to get there.
Yeah, that's
So how much time do you think?
like 1 minute.
Hour.
No, it's more than enough that.
How? It's
Right, one little timer that you have to go there. And count down from something to 0.
No, it's all right. Track. Actually, it's got a lot of.
Yeah. Okay.
So,
Very
sorry.
good.
Oh, hey, I'm like a close to friend.
Services you've been running for 6 years. So
Yeah.
I got a lot to say.
Can you
Next,
change the slide?
SKCD thing. Next slide.
It's gonna be only one slide.
It's all
And then
right.
after that,
I'll defer. I'll defer Leandro as well. It's all right.
Hello, everyone.
I need about 20 minutes to prepare the snacks for the break. Can you let me know 20 minutes up front? I need to heat them in the oven.
Depois da minha apresentação daqui. Deve ser daqui 1h30. Isso aí. Só me dá um toque. Ou senão você pode usar o clicker também.
Como é o nome desse?
Ilha.
Ilha.
Hello. So first, hello everyone, and thank you for coming to the opening of the MessageBird. And considering all the train cancellation, it's a quite good turnout. So thank you everyone for coming. Before we start, can you please say something about MessageBird?
I actually have something.
Yes, of course.
Can I
So I
just?
can imagine that most of you or some of you haven't heard about MessageBird, what we do. I think it's kind of like good to take this opportunity to introduce a little bit what is MessageBird. What is it, John? I'm not the biggest microphone guy, so let me try a little bit clear. So what I'm saying is basically what I'm trying to do is just introduce a little bit to you about MessageBird, what we do, what kind of problem we're trying to solve, what kind of a little bit of hiring here on this one. Right, so I'm Leandro, I'm the VP of engineering here at MessageBird. I've been with the team now almost close to 3 years and a half, and I have to say it's been a really interesting journey. I see some familiar faces here, some people who have been with us. So welcome back to our office, and of course, welcome everyone to this Go Lady Meetup. So basically, what do we do? So basically, we are building an omnichannel communication platform. A lot of times they say, I say those two words together, it doesn't mean a lot to people, but it's all about removing friction from how customers talk to businesses, right? That's kind of in the essence what we are trying to solve. If we look also from our vision perspective, it's enabling business to talk to their consumers as they talk to their friends, right? That's all about how can we remove the friction from that communication. I always like to talk about this, like looking back to our history, right? When we started 10 years ago, we actually started, and I don't know if this is common knowledge to this group, but MessageBird started together with Molly, which is another startup here in Amsterdam. I don't know if there's anyone from Molly here. probably not actually go. So MessageBird actually was born together with Molly, and at that time, there was a specific problem that came up while they were building a specific solution for payments, right? We started to see that when we were trying to send an SMS via the API, it was not as reliable as when you were actually just sending a text to your friend, right? So we started to question, like, why is this the case? Right? And we started to figure out there's a lot of problems behind the hood when you're trying to send SMS via APIs. So there are different routes, different ways that SMS were actually getting sent. And we started by trying to solve that problem specifically. How can we remove that friction and how SMS can actually reach end consumers when we're actually sending for an API? And that has been one of our first products that we actually started already with customers, right? And that's where we started building a communication platform and enabling this to send via APIs. And after that, that's also where we started the journey towards what we call the omnichannel platform. What we did with SMS, enabling communication and messages to be sent via API, and at that time you can think about like things like OTP messages, right? Payment reminders, all kind of reminders that you receive on SMS. A lot of this flow through our API. A lot of the Dutch traffic will go through messaging. And there's like, you can also do this with, for example, WhatsApp or Facebook Messenger. And we are creating this platform to enable business to actually communicate, automate communication, and build different kind of solutions on top of the platform that we have created and we have built. And as you can imagine, throughout this time, we have faced a lot of different challenges, right? If you think about scale, right? If you think about reliability. This has been a common problem that we have been trying to solve as we see different problems, as we grow, as we scale, right? And this is, of course, one of the reasons why we transition to GoLang, right? You can go to the next slide. Just to give us a little bit of story about this, I tried to collect some information from the people who have been here longer than me. And what I could get is that between 5 to 7 years ago, which is of course at the end of 2 years, but this is what I could get. Some people told me 5, some people told me 7, that we have been using Go. And there was a specific problem on our SMS stack that we couldn't scale beyond what we could get at that time. The SMS infrastructure has been built on PHP. It's still there. We haven't really rewritten or replatformed a big portion of it, just specific parts. But they're still there. But after that, all of our infrastructure, all of our products have been built in actually Go. That's where we are today. We keep improving our progress, building new progress, and everything, and now it's built in Go. And that's my next invitation to you. Check our website. We have open positions for Go. We have also positions for PhD, CFF friends, or if you are still also working on that, wanting to move to Go, there's also an opportunity to join us and help us building a communication platform of the future. With that, I want to welcome the next speaker, or actually, Ilya, welcome him. Thank you, everyone. Yeah.
Where's your? Thank you. All right. Let me know.
Yes, so thank you, MessageBird, for the wonderful introduction. And before we start, some simple formalities. So please join us on Slack. We would like to invite you guys to become a speaker at the next meetup, become a host, become a sponsor, become a co-organizer. Today, we will have 4 talks. We will start with Philip, Monads and Go. Then Gustavo, then we'll have a small break, then Eric, and lastly. So I would like to welcome Philip. Can you please come and tell us what you can about Monads and Go.
Just. All right. You can give the clicker. Just press next and.
Hello, everybody. Once. So, yeah. Well, everybody know what models are, right? Not a definition. It is a piece of manufacturer. The one that actually a country that's not a country. So, it's a thing. It's a thing, it's a very useful thing. Because it was invented to solve side effects in a functional way. Side effect is when an element is missing array, when the configuration is down. It's a side effect. So the way to address these side effects is actually a moment. And everybody, I believe, already used moments with promises in JavaScript. They are moments. For the context of this presentation, we're going to be that moments is just something that you can put something in a box. And in order to work with it, you need to have some kind of interface to take it out, change it, and put it back in the box again. So what this actually is helping us to achieve is have no null pointer exception, have no ignored errors. This is beautiful. That's it. So I'm good. I'm a Ruby developer. Yeah. It's It's a great company. We are providing appointment scheduling or scheduling. We have a very generous fee here. We are integrating with the resilience of payment gateways across all over the world with lots of SMS gateways. So practically you can run your business for free. Check it out, but please be careful. It's written in Ruby, so also you might wait if you. Yeah. How you know what it is, like railway oriented program, right? Everybody that do know railcars, yeah, it's just a simple idea. I would say it's something build a pipeline without if conditions. Basically, it's called railway oriented programming because you're going to follow a happy path, and when you encounter an error, you're going to jump to the not so happy path. And what's important to notice is you always get to the end. So there are no further returns, there are no, which can affect performance. But yeah, I don't think that performance is that expensive. I think also more expensive than performance. So what type of models we have? We have lots of different kinds. Like we have in some languages there is a native or optional, where you can wrap something or nothing. We have results that can wrap a result or an error. There are futures and lots of useful models. In our talk today, we're going to talk about result models, which I think it's very useful for Poland. All the others are also useful, but this one is kind of especially useful. So we're going to try to transform this on the website. This is like a normal everyday going program where you have something and then you're checking the error, then you do something else, then you check the error, and you do something else, check the error again, and on the other side, I think this is down. Where you have just a clean pipeline where you can see clearly what's going on. So you see the steps of the execution, there's no noise, nothing. So when you read the code, you exactly know what's going on. You can reorder it if you want, you can do anything. So I think this is a better way to write programs than this one here. And even this is a short method. I see the long methods and you have to get super tired by just glancing over simple methods. Basically, yeah, this is the only use I have in the slide. So this is how I feel when I read the code and when I write it also. Another fun part. Now with the generics, we actually can implement results very easy. You can have something, or you can have an error. And then you have those ISA helper functions where you can check if the result is acceptable or not. You can unwrap the result, where you can get that stuff that you put inside. And yeah, you can do failure, and you can get the error. And the most interesting thing is actually this guy here. It's fmap. By the definition, every monad is a functor, and functor has only one single interface. That's called fmap. This is not the correct definition of the interface. The correct one is in the functor, you have a function that translates something into something else. And then in the end, the fmap returns another function. So this is not correct, academically correct, but it's something that is, I find it more convenient for us for our examples. Another thing about core engineering. So initially, I started the whole thing. I wanted to check it out what are the capabilities of core engineers. And one thing they are missing is if you want to introduce new type when you're calling a method, you have to declare the type on the struct definition itself, right here on top, which really sucks. So, but I see a lot of people having complaints about this, and I believe it will be addressed in the near future. So if we apply this result monad and get mapping, then we're going to get the pipeline like this. It's much more clear. It's not that beautiful because I have to do all the fmaps here calls, which they naturally belong to the monad itself. So the result is not a monad because it doesn't apply to the monad interface. We can put it in a monad package, kind of make it look more like a monad, but it's not. But it's still a way to do everything and don't care about the others at all. This is one of the methods called. So instead of returning a combination of result and an error, we just return a result command. It will be really beautiful if we didn't have to do all these if conditions here, because this is actually another monad, it's a maybe. So, but yeah, for now, but most important is the part of the work, yeah. The part where the service, the business logic lies, it has to be readable, and it has to be like this. When they add support to introduce new types of the methods, then that actually, on the previous page, will look like this, which is way more beautiful. So, yeah, that's pretty much it. Conclusion, yeah, we already talked about it, but the things are moving in a good direction. That's my opinion about the language and everything.
Can you go back to two slides?
Yeah.
One more, yeah, one more further. Sorry, front to the front. Forward. Here, yeah, no, sorry, the one with the 4 line.
Yeah.
Here you have data is fmap token decrypt, and then user and fmap data.user ID. But isn't data here like your monad struct? So isn't data.user ID a syntax error here?
Yeah, it is. We can't do this. We actually need to unlock it to be the next one.
Okay, but then if you unwrap it, you still have to check if there's an error or not. So you still get the if statement.
Yeah, but
here.
that's not doing that for you.
Yeah. Okay, but that makes it a bit more complicated. So then you have to pass data in here, and then the fmap somehow has to know what. Yeah, okay, never mind.
Yeah.
No, you need the
I
functions.
get it.
Instructs-
Yeah, yeah,
I
exactly,
mean,
yeah. I get it. Okay. Any other questions? Sorry, can you just clarify a little bit more about why it's not possible to make it a member? Because if you want to do that, this app will have to have this signature of result. But when you want me to do some PNU, you also need to do it over here. So, yeah, I mean, it's first it's prestigious, but also it's not correct. Because that must be actually transformed to legal countries, not altering. Right now, it's
Next questions. When they ask a question, can you repeat? It's not the shop.
All right.
Thank you, Philip. Before we go any further, there is can the owner of the green motorbike, pick it up? They said they're gonna remove it if you don't.
Move it away.
Sorry. Okay.
You have to go.
Yeah, so thank you, Philip, for the talk, and Gustavo?
Yeah.
Now, let's see what's your talk about.
Hey everyone, to be proud. It's been a while since I've talked in public like that, so bear with me. I'm here to talk a bit about one of our services called HDQ. It's we call it Destroyer of Websites because it's basically a DDoS as a service. But I'm not here to talk about how we destroy services or anything. I'm here to talk about how to operate that thing and how we manage to deliver millions of webhooks daily. First of all, I needed to add that. My manager said, yeah, you should probably add that so people don't think we're kind of going through this. So it's basically saying that we are not doing any DDoS on purpose. The thing that we are doing here, that the people that actually got the DDoS, they kind of asked for it. We're not advocating for people to, oh, you're asking for it, but they kind of asked for it. Because they did the request, say, oh, sure, give me hundreds of thousands of requests in a few minutes. And, well, we did that. But we actually take that seriously. Like, we work with engineers and we work with operations everywhere to make sure that people take this kind of things seriously. And, yeah, disclaimer, we can go forward. But first, I wanted to say a bit about me, because this will explain a lot of our slides in the future. First of all, Gustavo Kamoto, I'm a Brazilian bird. I'm a bit slightly obsessed with cats. I'm a cat person, for those who couldn't say it from the picture. I've been on the tech world since 2006, I think, 2005. 17 years. 17 years. Since I've been developing, engineering, whatever you want to call it these days, and not well, the cool kids, so it's whatever. And I'm a business infra team lead at MessageBird. So at MessageBird, we have this team called Business Infra. We manage services that are basically helping our product teams do things. So to think about authentication, queues, preferences, anything that helps teams to do their things and not get messy about things that are shared. We are basically in the middle. These are the guys that kind of help me. Unfortunately, they're not able to be here because of the F-beam trains. Try not to curse, it's being recorded. But they are kind of helping me. They help us to build these things. And this is the cat of one of them. It actually has the same name as our manager. So it's all interconnected. And we at MessageBird, as Leandro said a bit, we are building a communications platform as a service. So we kind of got some big customers in between, so it kind of makes sense that we send a lot of requests everywhere. And that kind of size it makes us have a lot of challenges in between knowing how to scale things and how to innovate, but also how to operate and needs to be really creative on how to do things. Otherwise, things explode. And also, we're hiring. Please check out our careers page. And enough introductions. Let's talk about HPQ because this one is the actual thing. What is HPQ? HPQ was developed by one of our dinosaurs back in 2016. And yes, we call old people in MessageBird dinosaurs because we call our people birds, and the ancestors of birds are dinosaurs. So there's also that. It basically is a queue for webhooks, which means that any service inside MessageBird can connect to HPQ and say, oh, please deliver a webhook to xynz.com, and we'll take care of everything from there on. Like, we'll check the payload, we'll check if the URL is correct. We'll implement mechanisms to retry in case anything fails. And we'll even let people know that, oh, your webhook failed. You need to do something about it. So we are basically connecting MessageBird and their customers because a lot of our services inside MessageBird use them. For instance, Flows, which is one of the services that enables customers to actually write their own flow of communication in between the client and the customer itself. So a lot of those services do that, and to deliver things across a lot of different services in a consistent way, we actually came up with that service, HPQ, and we deliver like a lot of webhooks daily. Any idea on how much webhooks do we deliver a day on average? Raise your hand if you think tens of thousands. Okay, one. Raise your hand if you think hundreds of thousands. Okay, one as well. Tens of millions. All right, and hundreds of millions. Yeah, you don't count them, though. You know the answer. Okay, so for those who said hundreds of millions, yeah, that is true. We actually have like on the number of billions per month of webhooks delivered everywhere, and this is a bit on how the last month of August was. You can see like the first few days, basically destroying someone in China. I won't say names or clients, but one of our clients was basically running a big campaign, and we were delivering this webhooks. But what is actually composed of HPQ? And yeah, this is how we break down HPQ with a small number. HPQ is a single binary. Like in the past, it wasn't a single binary. Like it was built for multiple binaries in all sorts of ways. But since then, we've created a single binary that you can set up in your startup during your command line. We try as much as possible to follow the customer's goal. And if one of those developers that I mentioned here, Kevin, was here, he would just stand up and applaud because he loves that thing. But yeah, we try to keep it as simple as possible because that's when you reach to this kind of throughput, you need to try and keep simple. We are also secure by default, which means that we know who is coming through some mechanisms that we've implemented in GCP using GCP's IAM, so we can identify which services are connecting to us, and we also can. Our customers can also know that the webhooks are coming from us because we also sign our webhooks. So we like to say that we are secure by default, so people can understand that we know exactly what's coming and what's going. And HPQ is broken down in 3 components. The first of which being the API. I had a discussion today with Leandro about should I put REST or HTTP on top of there. But it's either way, We got APIs for both HTTP and gRPC. With a simple single endpoint where users can submit the webhooks saying, oh, go there and do that. It runs on Go standards, HTTP maps, which means that we don't use like HTTP router or whatever. We think the only dependency that we use is for gRPC itself. It needs to be globally available because we have like customers coming from all over the globe, and we need to deliver them under 250 milliseconds, which is our internal SLO. And we're doing quite all right with that. But and also it needs HPA. For those who don't know, it's horizontal block scaling, which adapts the traffic, not only based on the resources that we have, but also on the number of requests that we are serving. The API will send all of those requests to this guy called Beanstalk, which is basically a queue manager. And it's open source. You can check on the GitHub of Beanstalk. And it's quite simple. It's very easy to write a client, to write some nice implementation on top of it. As much as that we actually have written one of them. You can also check on the link down below. But even though it's simple, it has a lot of features that we actually use a lot. So it has delaying features, like you can say, oh, this job should take a while to be redelivered. That way we can do back off and retries and all sort of things. And finally, even though it's quite fast, it's still a single-threaded process. So we need to run it in multiple pods in order to be able to have an actual good throughput. After the job is posted to Beanstalk, we have this pod called Worker. It has a bunch of Go routines, and by a bunch I mean like at least 1,000 Go routines handling the requests from Beanstalk, which sends to more thousand Go routines, actually preparing the requests and sending those to the customer itself. This is a guy that deals damage to people. Like, he's prepared to send a lot of requests. He's port hungry. A lot of the ports and a lot of noisy neighbor issues that it had in the past was because of these guys handling, consuming a lot of ports. And yeah, it also needs webhooks. It also needs HPA to run because he needs to scale up and down. I'll go over that a bit in a bit. And our SLO as well. I wanted to put our SLO because it's interesting how we need to calculate those things. So this one in specific, we calculate by saying, oh, when did the requests came in? And how long did it take to actually deliver the webhook? And you were saying like 500 milliseconds from the time that it was posted up to the time that the client actually receives the webhook. And that's basically how it is broken down. Like the user basically reaches out to the API, it sends to Beanstalk, the Beanstalk sends the job to the worker. The worker will notify the client saying, oh, there it is in your user server. And then once the request is delivered, the worker will come back to the user who requested it and say, okay, I've delivered it. And everything goes to the stack driver database. I'll talk about that a bit. But yeah, it's fairly simple. But that is the part that sounds simple. How do we operate and how do we maintain this thing? You guys gotta remember that we have this service growing for almost 6 years already. So it's quite a few time and it has changed a lot over the years. Some of the old birds that are around here actually probably had contact with the service. And I've separated a few topics that I wanted to go through. The first of all is scaling HTTP. This thing needs to be multi-region because you actually need this to be running across multiple regions in order to be fair, to be actually fair growth. Having it like in a single region won't actually cut it because we depend on a lot of resources on the region itself. And it also depends a lot of on horizontal pod auto scale. What do we mean by that? Is that horizontal pod is that sometimes requests can come up during the middle of the night, during like off peak hours, and we need to be able to react to all those kind of things. So we got horizontal pod auto scaling set up to scale up the number of pods by a bunch of different metrics. So for instance, the number of workers that are actually being used at that time, or the number of requests that we're receiving. And since it's a multi-region thing, we need global load balancing and dedicated nodes because it's fairly easy for us that are consuming a lot of resources to run out of resources and start other processes. And finally, we need to figure out the actual resource code, the sweet spot. I don't know if you guys ever been through that, but the resource quota for a bot, it can be tricky to figure out, especially if you're running things that aren't exactly resource intensive, like sending web loads, that most of the requests are actually IO bound and not processing. So in order to do that, we do a lot of load testing with HPQ. And we're actually working out on a formula to calculate what do we expect on based on what the traffic is. And yeah. Second of all, HTTP2 clients. I don't know if you guys ever been through this or ever had a mysterious lock inside your client or your HTTP2 client. For some reason, your process was hugging. But we actually figured out that since Go 1.19 up until Go 1.17, Go itself had an issue that would lock our processes for up to 15 minutes. And that would happen at the worst times ever. Like, oh, it's 11 o'clock on a Friday. Sure, let's die. Why not? And yeah, we had a lot of sleepless nights trying to figure out what the hell was happening. And after bashing our heads for a long ass time, we actually found out an issue saying, oh, there's a process hugging there. There's an issue with the lock. So we need to fix that. And it actually took the guys, after we found the issue, almost 2 years to fix it. So we saw that issue in 2020, 2019, 2020, and the problem was only fixed on late 2021. So it took them a while to figure out and to decide on what the hell to do with that. So during that time when we were still flying, we needed to apply a small patch, monkey patch, just apply the patch, fix it, and let it run. It wasn't ideal because there were a bunch of other scenarios that we couldn't go through, but it was quite intensive. And I invite you guys to check out the issue for yourselves. And it's a ride, but it's fun. One other thing is that once we started developing HTTQ back in 2016, we used MySQL as our database. And I don't know about you guys, but I've always hated scaling databases, transactional databases specifically, because they simply don't scale easily. You need to be really creative. And not only that, but they can also get really expensive if you're running multi-region. And if you're running multi-region with throughput of millions and hundreds of millions per day, it can be really, really, really tricky. And at the end, we kind of figured out that we don't actually need databases. Databases are maybe the go-to solution for storing states for a lot of processes and a lot of the engineering that goes on everywhere. But it doesn't actually has to be the case. We can also embrace logging. We have a process that keeps the states for us called queue. Since we're using a queue, we don't actually need to worry about the state itself. We can worry about just auditing and managing what's going through. So we could just drop databases altogether. Like we're not using any kind of database. And I put some quotes in here, any kind of database, because we need to start it somewhere. But we're using actually logging. So if you have a good structured logging and you're making sure that your log's not blocking you from doing your things, then cloud logging will be your friend. And just make sure that you don't actually explode in costs. Because how much do you guys think it costs per month to run our HPQ server? Hundreds of thousands of euros? Raise your hands. Tens of thousands of euros. A few thousand euros? Less than 1,000 euros. Yeah, you guys would be surprised that it runs a few thousand euros per month. And this is actually something new because I actually got a small chart in here showing out the costs that we have. And if you look closely, by the end of June and beginning of July, we actually had quite a few costs with cloud logging. Because cloud logging is great to handle requests and to handle logging in general, but it's terrible to store things. It costs a lot. And by a lot, I'm even saying like 10 times the actual cost that we had in here. You can see a small spike in there, but that spike was not caused by storage. It was caused by people actually querying BigQuery. But by middle of July, we actually transitioned from storing everything in cloud logging to store in BigQuery. And then it's actually saving us a lot of money. We were running in the tens of thousands, and now it's running in the thousands. So yeah, use logging, but be aware that storage can be tricky. So yeah, conclusions. I've put some here. Design a system to solve your current problems. Once we've started designing HPQ, it was really helping a lot of people. It was working really great for a few years, but things change and we need to adapt and overcome. And so try to stay focused on your actual goal here. Like try to avoid overthinking and over-engineering and do your best to actually solve the problem. And once the problem arrives, just invest money, invest time to do so, and to figure out how to solve the problem, because it's well learned. It gets me quite proud to say, oh, we're sending hundreds of millions of requests per day, and but it doesn't come without a cost and without a lot of efforts. Also, services doesn't need to be expensive to do a lot of things. Like from HPQ itself, it's quite cheap if you select the right tools. Also, beware, issues exist everywhere, even in Golang. So if you got a weird hugging somewhere that you don't really know what's going on, don't be afraid to go deep and to check on someone else's code, because you might find issues. It's everywhere, no one's fail-proof. And just keep your mind open. And finally, be careful what you wish for, because people kind of don't expect to be answered when they wish for things. But just like 2 weeks ago, someone in a memorial website somewhere in the world asked for 400,000 requests, and we kind of delivered them in 30 minutes. And their website kind of went down for 3 hours. So try to avoid avoid wishes without well thinking, And I think that's it. Questions? Okay,
Yeah, and oh, no, you can repeat the question, it's easier.
all right.
I have a bunch of questions, but the first question is, what percentage of your customers or the webhooks is HTTP 2 and what percentage is just HTTP 1.1?
Oh, that's a tricky question because you could say that most of them are HTTP2, but that doesn't mean that the client itself is really HTTP2 because we got proxies in the middle. The customer itself not be on HTTP2, but it's requesting, it's receiving your HTTP2. I would say a lot of them. I don't have the exact numbers, but it's like the majority. All right. You go.
This question, how do you authorize your webhook?
We actually, how do we authorize our webhook? We have two separate. Yeah, just it. How do we authorize the webhook? And that's we actually have two methods of signing. The first is when someone asks for the webhook to be delivered. That is done with using a public-private key. So we basically have an audience that generates a key to be authenticated and validated by Google itself. And after we get the job to deliver the webhook, we generate a signature based on the URL and the payloads, and also a key from the user itself. That answer? Nice.
And then you rotate it.
Yeah, they can rotate the key, and the user itself can check the key, the validity of the key. Also, good tip: never accept webhooks that are not signed. There is a huge risk that you're having them in the middle of the time. So never forget to check your signatures.
One more question. So, you mentioned that you put those stuff, right? And
Yeah.
is there a way to control how many requests you can send? Or it's like, okay, I got a million and I
Yeah, you asked if we have like control over how many requests we send, and if we could just DDoS someone. And if I actually got a similar question this morning while we're doing the rehearsals. Like someone asked me, what would you do differently if you were to write HTTP from scratch nowadays? And the thing that I would change for sure is to write things based on resource quotas. Because right now we do have rate limiting, but it's not exactly equal to resource quotas. So we can cancel, but once they are delivered, it's kind of already gone. We have some methods to do things, but they're not automated. So, yeah. All right.
After operational downtime, how much is it go and do? How do you like it?
You asked for how much the downtime is related to Go itself, right? And yeah, the way that we designed the service itself, it's quite easy to move it around the world in different regions. So we actually experience very little downtime based on general failures on our cloud provider. What usually happens is that we need to figure out the resources. That's why we spent like the last few months of this year thinking and figuring out how to calculate that and to proactively set up resource quotas, because there are differences in between sending out slow webhooks, fast webhooks, and all the way in between. And because if you're sending a lot of slow webhooks, for instance, then you don't need a lot of resources because most of your workers will be waiting on I/O. But if you're sending up bunch of fast requests, then you need to set up a lot of resources. Otherwise, you won't be able to handle those. So I would say that it's for the past 2 years, maybe 50-50, because Go was actually a huge deal, and every time we would bump the Go's version, the problem would arise again, because we had a small patch. Yeah. So for the past 2 years, I would say that Go was a big player on that, but I don't expect that to be the real thing for the next few years. All right, you?
How many requests do you lose actually?
How many requests do we lose?
Yeah.
What do you mean?
You said you run Beanstalk. Beanstalk is a single threaded process. If it crashes,
Oh, we don't lose anything.
No?
No, we don't lose anything because Beanstalk is a single-threaded process. You've asked how many requests we lose since we run on Beanstalk. We don't lose anything because Beanstalk is a single-threaded process, but it's actually backed up in a persistent value. And it's still safe. Like we run 3 instances of Beanstalk every region, and we run like 5 different regions. So even if there was like a catastrophic failure, losing the entire persistent storage, we would still like have other 4 regions running out. So I could say like a very low percentage. Does that answer your question?
yes.
Yeah.
Especially.
Okay.
On peak moments, how many requests do you send per second?
How many requests we receive per second? Oh, we've handled 20,000 requests per second. And during the peak hours in January. Okay.
So you mentioned that you are running the HTTP with servers on information. So I'm curious to how do you handle the local language between them? And are they sharing any kind of state? Just like sharing shared states or clients on your side?
Yeah, that's you've asked if there's like a shared statement between regions, and I'm just repeating so that the recording actually gets it. So sorry for that, but you've asked if we have like a shared statement between regions, and no, we don't have shared states, and that is actually the main points on this slide here. They embrace logging and try to keep things simple. So you don't actually need shared states to keep up with that. And yeah, we don't share anything, but we do the balancing using global load balancer from Google. So we have a public entrance like that people can just join in, and the global load balancer guarantees us that our customers are reaching out the nearest server and
It's actually okay to for a single user to use multiple view at the same time.
yeah. We accept the requests that work.
So it's kind of a stateless. Okay.
Yeah, it's totally stateless. The only state that we store is in the queues itself, which is handled by Beanstalk.
So all of them share the same stuff.
No, we actually have different instances for different regions, and all of those instances are in high availability.
But yeah, that's right. So they share the same people. Multiple regions, so from multiple like peer circumstances, a user can like get STD surface, and then the next one will try to go another surface. So it's okay.
The Beanstalk itself, the Beanstalk server, it's not. They don't have like this huge high availability strategy like we have in other queues like Chicken Queue or like I don't know Kafka. They are single instances that we connect and we do the round robin. It's a good thing and a bad thing. A good thing because maintaining Beanstalk is fairly simple. But it's a bad thing because if we need to scale up, we need to really think about it. We need to organize so it doesn't mess with them. But whenever a client sends a request, we are the ones as the clients of Beanstalk, we are the ones deciding where to go. So that kind of takes from it takes the complexity from managing Beanstalk and the job distribution.
So like, is there any advantage of using Meetup instead of Meetup?
I'd say that the main thing is that it's fast and it's simple. Like the only thing that you actually need to do for Beanstalk to be running in a pod is set the limit CPU. Since it's a single threaded, it caps that it will throttle. But you set the CPU, set the memory, let them run. Of course, there's a limit, but since we are the ones in the client doing the distribution, you don't actually need to worry about adding more pods. So that's the beauty. And of course, there are problems. But you cannot update the job. There are a few things that you need to be really wary. But yeah, we actually thought about changing a few times, but it's hard to come with a solution that it's like that effective.
Any other services that you haven't had online? Like, maybe, like, what's like, I'm curious to what goes your question, like, what
We actually had tried with Bubsub. It was a disaster. Let's leave it at that. We actually discussed using ActiveMQ, Rabbit, but like I said, those have complexity of operating much higher than Beanstalk.
maybe it is
Uh, sorry,
a-
Redis.
Yeah.
Redis. Yeah, maybe, but the complexity of running Redis is quite high as well. We had good incidents with Redis in MessageBird as well. And yeah, like every time we try to contend with Beanstalk, and me, Gustavo, would say I'm not the hugest fan of Beanstalk, but it's hard to compete with that. So yeah. All right.
Thank you, Gustavo. So how about we take a short break? We come back at 8 for the other two talks and have fun and mingle.
But since you're using non-blocking logging, how do you deal with the possibility of that? Like emitting a log line might fail and that might affect your stats that you compute from logs, stuff like that.
We have a limit on what is expected to fail. And we also have metrics on entropy and heat. So we kind of know what's going on. And again,
since here. So I use that once in a while. It's frustration of like, this guy's basically transparent encryption thing on my database, and I was like, what's your model? And then I told them now they're switching to GitHub. Against it.
Yeah. I think it's something right, but yeah, that's the reason behind the private key, everything good.
Yeah, but that is true for a lot of things, not necessarily private. Because others, private parties will always ask, what if this? This. So you need to like explain every
Scenario.
everything like what you do with text compilers, because they have learned rightly that everything gets so
Yeah, that probably build up a
so,
lot of
there's
experience.
so many layers. The last layer is like literally that all the access log by Amazon, and they go directly into separate accounts. But those accounts need to be compromised first before they can save that environment. Those
You were on AWS.
yeah, the credit card is one of the few things that don't run in your own data center, because then they need to get the data centers, I said, 27001 certified, and they didn't take it. Right. So the thing is, if you run it, you can download all 3/4 of your PCI out of it, because they went through all those audits. If you think the right boxes, so you need to run on single tenant machines. They're super expensive because they basically use benefits of cloud. So they guarantee like anything that nobody else is on that same physical hardware. Then we got connects. So we got 4 dark fibers from our data centers. We had 2 data centers, 2 to 3 regions. Amazon hosted that service. Because even though we run HTTPS with mutual over, it needs to be dark fibers. Like we need a light path from one end from our data center to the other one, and then just for PCI.
I think it's offered that though, yeah. You can just the other units that can use that.
Yeah, but and they charge you 1,000 per fiber. They need to actually acquire the fibers from another provider, and then you lose like tens of thousands. Especially in the States where you need to per company once. Yeah, but they paid it for it. We store them and like everything has it's quite fun to.
Where's the stuff?
Right when you ship.
Yeah.
Your presentation is there.
I don't want to do this.
Problem is,
That is, if you have done it once.
So you're trying to
Makes
mass
too
effect the
money.
That is
and I don't want to switch until accidentally to show.
It's
No, I need Eric's presentation.
then it's and actually I need to share back.
Yes.
That's why I'm post this.
And
Yeah, I think
you can come over here
Oh, yeah, that one.
and there we go.
Eric,
Hey, don't forget the
you guys, can we start?
Yes. Let's make a joke of the going. You closest to
Okay, guys, please everyone take your seat. So, the next talk is, why do I need to read the body? Yeah. Sorry?
Read the budget. What's the budget? You need to read it without reading it.
I know why.
But in the agenda, it's like close to one. They will probably read their bodies. Huh? They will probably read their bodies, even it's back users.
Hey guys. Can we start? Okay. So, please tell us, why do we need to read the bottom? Yes. Okay. I will do a short lightning talk about the HTTP package and why you need to read the body. Here's some code. Can everyone see this code also in the back? I'm not sure how big I should make it. Yeah, good.
Stop the music.
Oh, the music. How do we stop the music?
That's really easy.
Yeah. Wait a second. More than 1 second. Wait, how do you switch? Oops. Okay, I'm just gonna shout really loud and then, oh yeah, if my slides are gonna go away, then I can't do so. Yeah. Don't applause yet. Yes, okay.
Yeah.
Okay. Yeah. Okay, why do you need to read the body? Okay, and I think this should be familiar to most people. Look quite familiar. Do an HTTP request, close the body, and read the body. But why? Why do you need to know about this? Copilot even suggests this automatically, so it's really a common pattern. But why is this a pattern? Why do I have to read the body if I'm not going to use it? It's in the documentation, so okay, I'm done. It says it's the caller's responsibility to close the body. The default HTTP client transport may not reuse the keep alive connection if the body is not completely enclosed. And why is that? I don't know if everyone's familiar here with how HTTP works, how keep alive connections work, but normally if you don't have a keep alive connection, you like open a connection, send the request, get the response, close the connection, the next request you're gonna open it again, etc., etc. That's slow. So you have persistent connections where you open a connection, you send a request, get a response, you send a new request, get a new response. It's much faster, especially these days when everything is HTTPS. You need to do like a TLS handshake. That's slow. So if you only have to do that once for open a connection, much better than having to do that every time and time again. But what if you don't read the response body? Well, if you don't read the response body, you get, oh, excuse my paint skills, but you get something like this, where you send a request, you get a response, but you don't read the response. And if you then want to send a new request on the same connection, then the response cannot be read because you're still reading the old response. So if you don't read the response body, the client is just going to open a new connection instead. So why, if I close a body, why doesn't it automatically read it for me? Well, of course it doesn't, because then what if a server sends back like a 1 or 100 gigabytes body, or even bigger? Like you could easily take some clients down by just sending huge bodies to them. So the developer has control over this. That's why you have to read the body, discard it if you don't want it, then close it, because then you can reuse the connection. What about the server side then? Because server side, we also receive a body. So do we also need to discard the body we receive if we're not going to use it? Because I don't see that very often. So no, you don't have to, but actually maybe you need to, because in the server side, there's actually some code that if you close a body, or if it's automatically closed at the end of a handler, it will read up to 256 kilobytes, and if the request body is bigger, it will still close the connection and not have a keep alive connection. But what about HTTP? Because these days most things are HTTP too. Is it still relevant here? No, it's not really relevant anymore, because with HTTP you have it multiplexes multiple requests over the same connection. So you still with HTTP2 only set up the connection once. If you don't read a body, doesn't matter. The next request will just be multiplexed over the same stream. But you might still want to actually read the body or discard it, because otherwise you're going to get like HTTP stream closed errors on your server side. The client side just doesn't do anything, leaves it all to the server, but the server might not like it if you don't read the body. And one more thing, I'm almost done. I see this happening, well, not that often, but sometimes. Please don't do this. Like, please don't create a client only for one request and then don't reuse that client. Because here you're also not getting keep alive connections. Because that state of the keep alive connection is bound to this client, but you're not reusing the client. So you're not reusing that connection. So you still don't have keep alive connections if I do something like this. That was really fast. Questions?
Obvious one. Can you spoon close and reading it close? So you fake it.
Yeah, how would you fake it?
That's my question.
No, you cannot. No, I wouldn't know how.
So you're actually so the only thing is actually read the message.
Yeah, you actually need to read the whole body and just discard it like most people do if you don't need it, because otherwise you really don't get any keep alive connection. Yes.
Are you dependent?
Sorry?
Are you dependent?
Oh, I use IO-Nutel. Oh, yeah, IO-Nutel doesn't read all is deprecated. That's IO that reads all now.
Yeah.
True.
It's not you, it's Copilot.
Huh?
It's not you, it's Copilot.
Oh, yeah, Copilot.
Yeah.
Yeah, okay. Wasn't me. Any other questions? In the back.
Can go one last slide back? There's a thing where it can keep the message open. Transport. You guys open, so you can close it.
Well, yeah, if you do this, then you will get the TCP connection open, but it sets some finalizer. So on the garbage collection cycle, when it sees that the client isn't being used anymore, it will still clean up the TCP connection. Luckily.
Okay, I know that the noise from the device because it kept spot voicing. Yes, what's about this?
Yeah, I already wrote some questions there for you. Make it easy. To be honest, I just built this presentation quickly today because we didn't have enough talks. I don't know about HTTP 3. I'm assuming it's the same as 2 where it is. Well, it doesn't use TCP, but it still multiplexes stuff over the same connection. Yes.
What about trailers?
Yeah, what about trailers? Well, I'm curious. Does everyone know what a trailer is? Like, has anyone ever used trailers? You tried using it. Oh wow, we have one person who actually used it. So, I also tried, yeah. So in HTTP you get headers first with data, then you get the body, and then optionally you have trailers after the body, which is just a header which comes after the body. So if you don't read the body, then you're not receiving the trailers. But it doesn't matter because no one uses them anyway. Yes. Yeah, so why doesn't the HTTP client automatically discards 256 bytes just like the server does? I don't know. I couldn't find it. It's why it doesn't. Like maybe someone here wants to make a pull request on Go to fix that or something. Any other questions? No? Reason why to not read your body? Well, a lot of times you want to do a GET request to, well, mostly POST request. Maybe you want to do a POST request to update some status somewhere or to whatever, trigger something, and you don't really care what you get back, and you still want to discard the body you have. Sometimes you don't care what you get back. Okay, I think that's it. Then we go to the next tool talk, please. You're up.
I'm not sure if the clicker works, but it works. Ooh.
Hello, everyone. I want to talk about CH1. It is how I make a high performance general library for ClickHouse. First off, the active ClickHouse. I don't want too much about the ClickHouse. First of all, the ClickHouse you can search the internet. It's open source, and all the data is columnar anyways, and it's also open source, and it's really fast and transparent and other features you can find in there. ClickHouse page, I don't know too much type about it. So, why I decided to create a new driver? Actually, I was looking for tensor database, and I found the ClickHouse was very fast, and I want to use it. But when I used a native driver in the ClickHouse, it wasn't fast. So this is very bad, and I decided to create a fast driver to achieve the ClickHouse speed. And ClickHouse has some protocol interface. Actually, has a HTTP interface. Very simple. You request to the HTTP and get rid of the JSON and some other formats. Also, it has a gRPC interface. Almost the same as HTTP and MySQL, PostgreSQL. I never use that, but I think they are pretty slow. And also, I use they have a native TCP for internal use and the replication use, and also you can use it as the driver. So I choose a native because it's fast. ClickHouse native protocol is extremely TCP and extended data and the block of data and streaming, and also planar. The driver should be read a column by column of data, actually block of column of column data, and also it uses little endian. This is very important because I use this to make the driver faster. Also use a city hash for CRC, and also use a for MessageBird for comparison between the clients. Okay, when I want to start to write the driver, first, like other protocols, I'm looking for documents, but in the document says we don't have any document. If we need a document, we better to read and reverse engineer the source code. Yeah, it's really sucks, but I want to use the ClickHouse server. I read the C++ codes. You can imagine. But now they have some documents for the screen. They are not up to date and changed. Every version they change the protocol and it doesn't update the ClickHouse. Actually, ClickHouse has really bad documents. Okay, I never write any library before that, and I never know how to write a good driver. So I decided to read other drivers. I see and use PGX, really good driver. It's for the Postgres, and also I copy some codes and it's open source. Config parser and I copied all that from the PGX, and also I changed it to the compatible with the ClickHouse. Also, I review Python and Golang library and reverse engineer ClickHouse clients. Okay, before that, ClickHouse has some data types. Normal integers, also digit integers, enums, and dates, and decimals, and also it has a string. All of these types is a fixed type. This is important, the fixed size types, except string. We have most of these types in the PHP. For example, unit 16, unit 32, and so on. And also, ClickHouse has some complex data types, array, local multi, map, analytical data types. And I'm sorry, I'm going very fast because it's a lot of slides, and I want to finish it in an hour. Okay. Here I use generic. Actually, everyone after no release generic wants to use it, but no one knows how to use it because before that we used everything without generic, and now we have it and we don't know how to use it. Finally, I found it, and I'm really happy. I have an interface that implements every other structure we implement this. It has for generic, you need to use a variable, a type here, a type name T, and accept anything. It's interface also. I shouldn't be use any here because you can't use any types, but for some other reasons, I choose this because some limits, we have some limits in the Go generic. And also, it has some methods. Data read row is for reading data, and also it's append for writing data to the buffer, then sending data to the ClickHouse. Also for knowledge, it has the same, but with a pointer for knowledge data. You can see I have just one struct for reading all fixed the data types, except the string because it's a little different, and I don't want to talk about it. Here I use comparable because I don't use any comparable. It's I don't know. This is frame design in the Go that use comparable. We can read. We can have another talk about the generic to say why it's frame design. But if you want to use the type in the map, you need to use comparable to compare values. I use comparable here, and this is have some property size is the size of this variable. If it's for example unit 64, it is 8 bytes, and number of rows. We should know how many rows in the disk block we have. This B is actually the bytes that the raw data that we read from the ClickHouse. Also values is the T type. Again, this is data that you want to write to the ClickHouse. You can see here, I actually use the unsafe cipher from the T to know this size and validate the CHCOM validate to make sure this size is the same as size in the ClickHouse. So to read the exact size. And here you see this is the size of its method in the unsafe package, but actually it's safe. You can use it. I don't know why they put it in the unsafe package. What was the big integers? Actually, in the next slides, I can explain it, how I read any types from the ClickHouse to any types in the Golang. But for big integers, any big integer has a lower and upper. For example, for unit 128, it has a lower unit 64 and high value. So in this library, I just create this type, and I can create data and put it into this structure. And also for array, I don't want to more talk about other complex type. It has the same user generate, has the same methods, what getting the array of data. And about dates, if you want to read, actually ClickHouse in the date types, you use the integers. For example, for date time, we use Unix 32 and just say that the Unix understand. But if you want to use it, Google time, in the same time, I defined this date. In the generate, you can define interface and use the generate you can see this in this example. Any type should be defined. Actually, they all should be comparable and define these methods. For example, this is for date time. The main type is 32. The hospital value is this side, and then just convert it and use it the Unix time stamp. For example, from time, just call this function and get the converted to the date time from the Unix time stamp. Okay, I want also to talk about the goal optimization and how I use this in this library. Memory allocation, when Go try to allocate a memory, there is a lot of scenarios. I don't want to talk about all this. You can see the command document when you declare the variable, you use the built-in function like new and make, when you convert the string to the byte and byte to the string, and a lot of ways to Go try to allocate the memory. But Go wasting memory. Maybe someone knows about it, maybe doesn't know about it. But to better understand, I have an example. Memory blocks size classes in the Go is predefined. The small size is 8, 16.4, and so on until 32 kilobytes. If you have more than 32 kilobytes, you want to allocate more than 32 kilobytes, Go also need actually split it to the base side and need 48 kilobytes for page size. I can show you in this example, we have a array 48. So the size of T is 40. You can see here that I use the unsafe size of it's 40. Okay, it's normal. And I allocate the memory in this function F, and you can see when I call the allocated byte per operation, it's 48. Why it's actually allocate 8 more bytes? Because 4 bytes is less than it's between 32 and 48. So Go allocate 48. Why Go do this? Why just not allocate 40? Because straight up and wants to make a little bit faster and also allocate a little bit memory again. Yeah. And also you can see here we allocate 1 more byte than 32 kilobytes. And Go here allocate 40 kilobytes because of allocate more 8 kilobytes for memory. We should know about this so to actually know when we see allocates and maybe different than the size of the variable. Okay, we know about the heap and stack. When you program the start, it's from the 0, 0, 0, and then we have a heap or maybe a stack, and then we have a stack. We know the stack is fast because it knows about the size, and after finishing the function, it will be erased and so on. But for the heap, you have always have a problem with the heap. And GC work here to clear the heap. I don't want to work about it, but what is escape? Escaping the Go. Everyone knows this code works in the Go, but this code is the same. It doesn't work in the C. Everyone knows why this is not working in the C. Yeah, because this defined it in the this data defined it in the stack, and when this function finished, it returns to the pointer to the invalid data. And when you compile it, maybe you just compiler give you some warning. And what in this code, actually Go compiler is smart. And when you define it, you return it, the pointer of this data is moved to the heap. So it is good, but make your application slower. So how can I analyze my code to make sure which variable goes to the heap? A great specific example, you can see I defined the A and equal 1 and B equal false and C is a channel and use B and A if B is true, A plus plus, and then close the channel and print the data. And when I want with GC like dash N or dash double N, also with multiples, you can see in this line I have this message that told us move to the heap A. Move A to the heap because we use it in the another routine and it's need to move to the heap. But why we use B here? Why it doesn't move? Again, because we don't change it to B, and the compiler knows about it, and it's small. But what about the C? Why we don't have the C? C is in the stack? No, every channel actually the data on the channel will be in the heap, but because always move to the heap, the compiler doesn't show any message here. I have some tips about allocating. There's a lot of things about allocating in the memory. But if you know the size of your array or you know about it, you can reallocate it memory at once. For example, if you have an array and you want to put it in the for and append the data, it's better to first allocate all data before the for and then use it after with some tab size. And you can see I use this for base, set right buffer size. So if the cap of the value is less than the row, it's try to allocate the memory at once. So if other function like append, I append multiple times values, it doesn't reallocate the memory. And also, it's better to reuse allocated variables. If you have some variables like you can use simple, also sometimes, for example, in the base, I have one function which says when the system doesn't need that variable, it just calls it this function and reuse this variable in another request. What about function inlining? This is really important for making the faster programs. We always want to write functions because make our code twins. But functions is not good for performance or running because at the runtime it needs to switch between the functions and make it a stack and so on. This is actually have some. This is expensive to run other functions. A compiler tries to actually inline functions. When you have a small function and put it in the code, the compiler tries to copy the data to that lines, and it's just like you don't write the functions, it's the copy of the functions. So it's better to have inline functions for small, when, for example, we want to call a function in the for with a million times, it's better to make that function inline. But Go decide to make this function inline. There's some rules that Go decide to make this function rule. It should be less than 80 budget, ASD 80 budgets. Also, it shouldn't have contain complex things that like closure, defer, recover, select. But I see in the new version, actually when you use select, in some case also correctly inline, it shouldn't be have some purpose like go in and no inline. If you wanted to don't inline this function, you can tell to the go, but you can't tell to the go make this function inline. Yeah. Also, I use in this library, in this library for inline function, I use really small functions and make sure this function will be inline to make this faster. And also, I use an unsafe pointer. Unsafe pointer is good to use to make function faster, but it's redundant. And if you do something wrong, sometimes you get some really weird thing in your code. There's some conversation rule. In the unsafe pointer, we have two types of the function. It's really important to know like the difference between these types. We have unsafe pointer and we have PTR. The difference between these two types is a pointer, unsafe pointer is really actually the pointer. But unit PTR is an integer that's maybe mentioned to the memory. But it is an integer. You can convert the pointer of any values to the unsafe pointer. And also you can convert pointer to any type of the pointer of the any types of values. But the unsafe converting unsafe pointer. Unsafe pointer has 6 patterns. I don't want to talk about all patterns. Some of them is important, some of them is not common. One of them is if you want to convert from one type to another type, you can use unsafe pointer. But T1 must not be smaller than T2. This is really important. For example, I took this example is from Meetup Golang, the MessageBird Golang to convert float to Uint64 by bits, not casting. It's really different. This is not about the casting values. It's about the converting the data from the memory. Actually, we told to the Go consider this type to this type without any allocation, without any process. And also, I have this byte slice to a string. We can convert byte slice to the string. But we can't convert with this way, convert a string to the byte array. Anyone knows why we can't with this way? We can convert byte string to this string, but with this way we can convert a string to the byte array. We have this rule. T1 must not be smaller than T2.
Because only my take all from 1 byte.
Yeah, it has more bytes. Byte string, actually, the byte string has data. It's actually a struct with data that points to the data and cap and length. But this string has a pointer to the data and the length, and it doesn't have a cap. So we can convert it byte string to this string because the T1 not be smaller than T2, but for the string it's smaller, so you can convert it. This is really uncommon. If you want to, you can convert the pointer to the unit PTR. You can see it has the same result. If we get the address of the T, it's the same as in PTR because it also show the pointer to the T variable, but it's not pointer. It's really important to know. Converting of the pointer to the unit pointer and with arithmetic, because we can, for example, plus, minus, because unit PTR actually is an integer. And It's a little maybe complicated. We want to actually use it's just maybe game. We want to, in this example, we want to get index of y2 from the point of t. How we can do that? It's just a game with a integer. I don't want to do more talk about it. Okay, I'm saying pointer in the calling syscall. I forgot to tell you. We can do that. We can have any function that has integer in the input. During that because compiler doesn't know and maybe clean the memory because integer is the integer. But the syscall has this integer. What syscall has it, but we can define it. It's actually for syscall compiler, make sure to keep the variable for integer in this function. This is really important. I have an example to call it a syscall for any other functions that we want to use that accept the integer. In this example, you can call a syscall for example here I call syscall and some first input and the second input I use for the fp that return the integer for this function. This is a good way to call it, but this is not good. And this is maybe made to application saying why I save the integer in the U and then call it. This is dangerous. Why this is dangerous? Because in this line, we actually file doesn't reference to anyone. We save it in the U and it doesn't reference to anyone. So at this line, file doesn't reference it and maybe garbage collector decided if it's run it in this garbage collector run it in this line, actually file will be reallocated by another memory or even another program. And when you call it the syscall, this U doesn't reference it to the file pointer. This is why this is dangerous. And it's really hard to find it also. Also, if you use reflex, I never use reflex in my library because it's slower. But if you want to return back reflex from the value out to the main part, you can use the unsafe here. Pattern 6, you should see this is a lot in many of the programs. If you want to change it byte to the string and also a string to the byte without allocation, this is a way that we use it. This is some way that without allocation, because if you change it a string to the byte, it's allocated new memory, but this way it doesn't allocate it. But also this is dangerous if you don't know about the UEPTR. I can show you in this example, this is a real example. Actually, this is code is from the EasyJSON. EasyJSON is a library that's very used in to converting to parsing the JSON. It's really fast and used a lot. But they have this part. This is the first code, and it should be changed to this. I told you because we can use a really simple way to convert the byte to the string because it's not smaller than T1, is not smaller than T2. Here, for example, why this is unsafe? Here you can see that an example, we have the bytes and call this function and hit S. Okay, this function is small. So it's converted to the, it's inlined when it's compiled. So we have actually this function. Anyone know why this is dangerous here and why sometimes it's really rarely. I need your program maybe works for days or weeks, then sometimes the system rolls. and it's really hard to find it. So anyone can tell me why this is unsafe? Not you? Because you found it. Sorry? Where? Um, yeah, actually, yeah, you're right. Actually, Eric found it in the EasyJSON, and yeah, this is why unsafe is really unsafe, and it's very hard to find it. Okay, now how I use this in my library to make faster. First of all, because I use TCP, and when you use TCP and you don't want to read all the data, you just want to read part of data, and you have a streaming of data, it's better to use buffer.io. Buffer.io is a buffer that actually buffer you produce the data, and you can read it from the buffer, and producer doesn't need to wait to read the data. So you can, I use this for reading and writing from the ClickHouse, and some type of size. I can show you here. Producer actually send this data, and the reader only read A, B, C, D, and then producer write another data and doesn't wait for the reader to the read data. So if you want to read streaming data, it's really better to use Papaya to make your application faster. But for reading data, as I told you, ClickHouse actually send data in the cloud now, and also it's on the Little India. I think this code is running on the Little India CPUs. We have two kinds of CPUs, the Little India CPUs and Big India CPUs. The Little India and Big India is about how to save the order of the bytes saved in the memory for the integers. So if most of the CPUs are to use the Little India, it's really hard to find the CPU that uses the Big India. So I told you we use actually in the base we use the data from the ClickHouse saved in the key. I don't want to talk how to read the data from the ClickHouse. It's very important. And then I use unsafe pointer converted to the array of the T without any allocation, without any process. It's already ready to read. Because of that fact, it doesn't do anything. And also for read and for row also, you can decide to find the buffer data and just convert it to that type. What about atom data when we want to write data? It's also first it happens to the buffer, and next we can see here this area of this data converted to the bytes without any allocation, because the data already ready in the memory. But the important thing is I added some build tags on top of the file to make sure this is run only on the Little India CPU, not on the Big India. For the Big India, you should be reversing this bytes to make sure that this is going to be converted to the Big India part. All this CPU are with the Little India. This is what I've never the any Big Indian CPUs in the server. Okay, now an example. This example is really like other drivers. I've never used the data SQL because it makes slower, and I need to implement a lot of things that make the flight interface, and also it's neat to read the raw of data, but this is a columnar interface, so I've never used the data SQL. It uses the pool of connection and then send the P function and also create the table here with two columns, one using 64 and another 64 using 64. And now we want to insert data. First of all, we need to create the columns. Here you can see with new with the golden type, and then another one for nullable, also the new living type, and that nullable to make this structure this object nullable. Then we want to insert a million reports in 10 types. Actually, we want to insert 10 million reports. And here I set white buffer size because I know the size to the million. So I allocated the one time. Then we have a 4 inserted 10 times. Then a million times it's append the data to the buffer. And here it's inserted to the clue cost. Then we want to visit this data. Okay, again, we can use the old columns, and I just prefer to create the new, the same, but we don't need the buffer here because that buffer only for writing. And I use select and doesn't matter close, different close, and here we read data block of block, and we can use the function to read the data. And we read all data, and then print the how much time does it take. This is the result. Actually, it's inserted 10 million rows in my laptop and in the server 1.2 seconds, and selected 10 million rows in less than 1 second. This is a benchmark between the drivers. Has more drivers that more than this. I just added most famous and have more performance. CH2 both costs and upgrades. Total cost is native, and CH2 also actually it also has a really good performance. And upgrades added for you to start inserting data. And you can see I have Vortex inserting 100 million, selecting 100 million records, selecting 10 million streams, and inserting 10 million records. And you can see Station is faster in inserting because actually I write this driver for inserting. I never want to select this amount of data, but for inserting, I always want to insert a lot of data. And you can see it's really faster than other development drivers. And for allocating, you can see Station use really less than they are really big. You can see here. And for allocating, you can see it's just 35 allocate per operation. It's really low because it reuse the old variables and doesn't try to allocate the new from the heap. This is why this driver is faster. You can see that they all allocate a lot of memory because view, interface, reflect, and other stuff. That's much. Thank you.
Okay. Yeah. So first up, this is really cool. I'm so impressed, and I've been reading how the report would go. And I don't know how to go and so it really connects to the life. So I'm kind of struggling to understand the generic kind of aspect of it. So, and again, like most Go 118 users, I'm not so familiar with generic. So, but as far as I understand, so when you were showing the structure, the basic implementation of your interface profile, are you not paying a penalty when you have any type? So isn't there a penalty for a lookup or a type? Yeah.
Yes.
Right. Yeah, but like if it happens constraint, like if you have a comparison constraint and there was some other kind of constraint, then as far as I understand it, the type lookup will go is very fast. But the moment that you move to any type, for example, then the lookups are much slower. I think. Isn't that the case?
That's what I wanted to give you.
Okay.
A different purpose to your question?
Again.
Can you repeat your question another way? Understand it?
Well, so as far as I understand, your main goal is performance, right? I mean, you want to have super fast insert, you want to take advantage of the
Doesn't start
performance.
to every other.
So
Yeah, it's been
I'm
in there
wondering if
for
you getting some
since
specialty for
half a month ago.
users of generic
Oh,
skill. Maybe I don't fully understand the value of that, right? So.
That's not.
Yeah.
Yeah.
What?
Things apparently are there.
Yeah, that's why I want to see if there's a better.
Go generics are not resolved at compile time completely, because the overhead is really small. Like, yes, you could make it slightly faster by not using generics, but in this case, this library, it outweighs the ease of use. Like, at first he wrote a version without generics, and then to use that is actually quite tiresome because all the different types and stuff. So that's why the slight overhead of using generics is worth it in this case.
Yeah, and also this is like an handle all these types.
Yeah.
And usually the version before the actually generic, I created a lot of structs for every of these types. So this version doesn't need it.
Yeah, thanks a lot for the talk. And we to use it unsafe everywhere. How do you make sure that the correctness of your code and they like make sure that everything works? And do you use like go fast or something to test the code?
I use the unit test for
Just to use.
yeah. As actually integration test and unit test, also integration test. To make sure it works with the cookouts in the actually with a lot of version of the cookouts and 4 or 5 version of the cookouts, one in zero click, a lot of workloads in the unit test. Yeah.
How do you catch? So I would like to know average that you come on unit test or anything kind of that.
And the unit test, I never try it to make you have about the escape anomaly, right?
Yeah, when I have like different ways that I need with the privacy and then for all that things that right? And then you pass it to us as call and then we can use that object just like catching something.
No. Those bugs are really hard to catch. You cannot automate the catch that usually.
Then what is use case having that class file?
If you case about using the queue house, actually, if you use the queue house, you really need to, because you use the queue house because it's fast. If you don't need you don't need to make your application fast, you don't need to use the queue house. So if you use the queue house, you need to exert very fast. So actually, in this program, mainly on the my practice on the insert. Also, the second thing very good, like my main focus is on the insert. For example, in this library, you don't need to first actually sending the query to the database. You can first insert it to the buffer, and when you need to insert the data to the queue house, you can just send it the buffer, and the buffer already ready, and you don't need to do any start and any converting to convert your data to the queue house protocol.
I'm not very experienced with this thing, but my company use multiple to read certain large companies. Like, how does this performance improvement compare to the company? It's a tool that grabs a buffer of things and it's good for all your own.
If it's Go, then it probably uses one of these drivers and it's slower.
And you, so on the booking of that, we already async that's a job, which uses buffer, I think, and then just the buffer. Instead of every like blocks, do you do that not? Or I can answer that.
Can't get the question.
It's fine.
Yeah. Just open talk.
Okay, so that's it for today. We had 4 amazing talks. I hope you guys enjoyed it as much as I did. I would like to say thank you again to MessageBird for hosting us. So we will also have probably next meetup at end of September. The details are still pending, so they will be
On the 28th of September.
Oh, is it already done?
Wednesday 28th. That's
Okay,
not
so-
Pirates.
Wednesday, 28th at Club Pirates. I would also ask to call Gustavo.
All right.
So we have a small gesture for the people that talk, that gave a talk. So an awesome Go Cup for you. And another one for you. Yeah, and also we have something for the people that gave a lightning talk. Unfortunately, Philip left, so Eric. So Eric, you already grabbed one from the table.
Yeah. Thank you.
Yeah, you're welcome. So we still have about 25 minutes, so we can mingle, talk, have fun, and there's also some snacks at the bar. So let's say again, thank you, MessageBird, and thank you everyone for coming to and don't forget to call us if you want to host.
All right. I'm dropping out the meeting.